Hello students, you are here with teacher Walter. I'm a math teacher, and we are going to deal with the theories of mathematics senior 6 in the Rwanda Education Board. So this curriculum of Rwanda Education Board is where we shall find this content. So we are here with the complex numbers. This is the first unit we are going to deal with, but later on we shall have also many other units that we have to deal with. So let me take you through the first lesson, which will be the introduction on complex number. Introduction on complex numbers. Within this introduction, we shall talk about why were complex numbers there and where were they from, and why were they invented, and what were they to solve. So complex numbers, before we go for them, you all used to work within the set, different sets. Among others, they include the set of natural numbers, they include the set of integers, Z. They also include the set of rational numbers, and they also include the biggest set that I know that most of you were aware of, which is the set of real numbers. So we are going to start with a small activity. I will ask you to try to solve the equation x squared plus 4 equals to 0 in the set of real numbers. So if we try to solve this equation x squared plus 4, which is equal to 0 in the set of real numbers, as a solution, you shall see that if everyone tries it, we shall see that x squared plus 4 equals to 0. This means that x squared equals to negative 4. And then to get x, we shall have plus or minus square roots of negative 4. Many of you, when you reach here, you will see that it is impossible to find the set of, to find the square roots of negative numbers in the set of real numbers. So we shall say that there is no solution in the set of real numbers. Why there is no solution? There is no solution because it is not easy and it is impossible for us, as we use it even in our calculators normally, it's not easy to find the square roots of negative numbers. We are all used to find the square roots of positive numbers. So here, this was a big problem. It was impossible to find the square roots of negative numbers because they were used to find the square roots of only positive numbers. So mathematicians, especially the ancient mathematicians from Greek and Italia, the Italian mathematicians and the Greek ones, they have invented another set which will be helping us to find the square roots of also negative numbers, which means that here the square roots, the set of real numbers were not sufficient. They have tried to find another set in which we should be able to find the square roots of negative numbers, and this is the one I'm going to take you through, which is the set of complex numbers. So what is now the set of complex numbers all about? We shall see that for the mathematician to solve this problem, they have tried to take one real number, they have crossed it with another real number, and they have found now a new set, which is C, and which is called the set of complex numbers. So here, we shall take a number A, which is a real number, we shall take another number B, which is also another real number, and here, we shall immediately get a number Z, which will be equal to A plus BI. I'm sure many people will ask me, why is now there two things? That's why the set were called the set of complex numbers, because they were made by more than one real number. So we shall see now that we have two parts. There is the first part without I, there is another part with I. So this first part is called the real part. This is the real part of the complex number Z, and we normally write it this way. So we also denote this part B, which is called the imaginary part of the complex number Z. This one is called the imaginary part of the complex number Z. So if a number can be written in this form as Z, which is equal to A plus BI, this number will be called the complex number. So we can have here many examples. We shall now deal with examples. The first example I will show you is Z, which is equal to 5 plus 4I. So this is a complex number. Why? Because we can have that the real part of Z equals to 5 and the imaginary part of Z equals here to 4. So as we can find the two parts, it means that this is a complex number. So the second example, I'll give you Z, which is equal to negative 4I. This is also a complex number. Many students will be confused saying that there is no real part. The real part is there. Remember also that 0 is a real number. And we have said that A must be a real number and B must be a real number. So here we have now, we have that the real part equals to 0 and the imaginary part of Z equals to negative 4. So the problem will be now to make the difference between the two complex numbers. This complex number where the real part equals to 0 but the imaginary part is different from 0, this is called the purely imaginary number. It's a purely imaginary number because the real part equals to 0. The second case, the third example I'm going to give you, the third example is Z, which is equal to negative 2. This one is also a complex number. Many of you will just be confused saying that it's only a real number, but it's also a complex number because we should have that the real part of Z equals to 0 and the imaginary part of Z equals to, the real part is negative 2 and the imaginary part is 0. And now here, wherever we have a real part and we don't have an imaginary part because it is 0, we have what we call a pure real number. This is a real number, or simply we call it, we say it's a real number. This is a real number. And then from here we notice something. We notice that from this example we notice something. We are going to notice that all real numbers are included, or they are subsets of the set of complex numbers. Here it means that every real number is also a complex number, which means that the real part is there but the imaginary part is 0. So here we have what you call a pure real part. So here now, I think here everyone now is able to give an example of a complex number which must be including both at the same time the real part and the imaginary part. I'm going to review with a small exercise. Which will be asking you to, for each of the following, find the real part of Z and the imaginary part of Z. The first one we try is Z, which is equal to 0. We show whether it is a complex number by showing the real part and the imaginary part. The second one is z, which is equal to 2 plus 3i. The last one is 3, which is z, which is equal to 1 over 2 plus square roots of 2 over 2i. So here you will try through these 3 exercises, and we'll be showing at the same time the real part and the imaginary part. And if you reach on finding them, it means that you have been able to understand what is a complex number. Thank you very much. This is the end of our lesson. And for more details, notes, exercise, evaluation, and everything, visit our website www.ubumenyi.net, or you can visit again our YouTube channel. For the next videos, it is Ikaram TV. Thank you very much. It was with you, Teacher Walter. See you next.